In this video, we will use complex IMEXP, IMPOWER, IMREAL, and SERIESSUM to generate Euler's sine formula. We begin with the values of V, which is data validation, list of items, 0.5 to 2. So copy, it's 0.5 to 2. We can start with 0.5. Likewise for W. So data validation, list of items, and this will be 2, 3, 4, and 5. 2, 3, 4, and 5. We can start with 2. And for the expansion, so copy this and paste. And we change the color to red. Now we complete the sine function, the Euler's sine function. So array formula. We start with the inner part, minus Vx plus Wxi. So complex minus V times x, comma, Wxi. So W times x, and enter. So we have completed the inner part. Now it is the Euler's value. So this will be, we will use the in x. So in x, that is the Euler's number. So e raised to the power the complex number to the power n. Just the complex number. Now that we have the Euler's, we are interested on the imaginary part. So next will be imaginary the complex number. So here's the sine of the Euler's, the sine formula of the Euler's formula. Next we continue with the expansion, which is the summation of a times x to the power of n, where n is from 0 to infinity. In this case, 27 is good enough for infinity. And the value of a is equals array formula. We begin with the innermost part, which is minus v plus wi. So complex minus v, comma, wi. Next, we raise this to the power n. So this is raised to the power n. So that is IMPOWER. IMPOWER. Complex number raised to the power n. So the power will be n. And finally, we are interested in the imaginary part. So we factor in imaginary. Now that we have the imaginary, we can now divide this by the denominator, which is factorial n. So this is factorial of n. And now we can complete the expansion. So array formula, series sum of the x values raised to the power n, where n starts from 0, incremented by 1. And the coefficient will be this range. And we'll chart this. Insert chart. And we use scatter chart. Use column as label. We don't need the title. but we'll show the trend line. So under series, show the trend line. The type, polynomial. The degree, 10. For the label, use the equation. So here we have our trend line and polynomial. So we can change this. We increase the frequency of W to 3. We can also increase this to 3. Now they're the same. Change this W to 4. We can also change W to 4. Now they're the same. W equals 5. Increase this to 5. Suppose I go to V equals 1. So starting from 2. So this will be 1 also. Increase W to 3. I'll increase the red one to 3. Increase the blue one to 4. The expansion, increase it to W to 4. Increase the Euler's sine formula to 5. I can increase this also to 5. We change this to 2 and we start from 2. This will be 2 also. And we can start from 2. Change the frequency to 3. I can change this to 3. Now they're the same. Change the frequency to 4. I'll change this to 4. Change this to 5. Change this to 5. There's an error here because that's the limit. Our n is not infinity, it's up to 27. But if you increase this to 100, this error will disappear. This completes the use of complex IMEXP or the Euler's number, IMPOWER, IMREAL, and SERIESSUM, thermochlorine SERIESSUM, to show the Euler's sine formula.